Hey guys, for this part we're gonna start showing how to set up our different uh, dimensions and parameters for our project. In this case our project is gonna be for our 2D simulation of a cylinder. So once we open up our workbench, we're gonna have to go here where it says fluid flow, and we're gonna select the one that says fluid. We double click on that, we're gonna have this new window. In this window we're going to have the different steps that are required to set up to get our results for our project. In this first part is going to be our geometry. That's going to be where we're going to have to set up the dimensions of our cylinder and our control volume. Our mesh is going to be where our uh, inlet and outlet is going to be for the fluid. In this case, uh, we're gonna have to use that right after our geometry. Our setup is gonna be where we set up our different velocities or viscosity or our kind of fluid. In this case we're gonna be using air. Our solution is we're gonna be seeing our resolution, and the results is where we're gonna be getting our results. So as we can see, we have these little things. That means that it's not ready. So we're gonna click on the first one, which is the geometry. We're gonna right click on that, and we're gonna use the new design modular geometry. We can use that one or the other one, that's the new space climb geometry, but honestly I don't know how to use it, so we're just gonna use this one. We click on that and we just give it a couple seconds until it loads up. Once it loads up, we're gonna select our X and Y plane. Since we're gonna be using just a 2D angle, 2D plane, excuse me, we're gonna have to just look at it from our Z axis. As we can see, we have our 2D plane, the X and the Y, but we don't have anything here yet. So we're gonna start by sketching, and we're gonna go and select sketching and then circle, and from the middle part we're gonna select we're gonna start making our cylinder. So we click on that, but we don't know the dimensions yet, and our project says that it has to be 1 diameter. So we're gonna go there, we're gonna select that, and here we got 13. We just gotta put it as 1. Boom, easy as that. We're gonna have to draw again. Now we're gonna be working on our control volume. We're gonna go from the middle part, and then boom, and then we're gonna go and have our vertical distance, and we're gonna do the same thing for the other side. Excuse me. This will be, and boom. But our dimension has to be 25 by 25 by 25 by 25. Well, 50 by 50, but you know, every line has to be 25 by 25. So now we're gonna have to see our dimensions. We go under general, we select here, we go here, we go here, here. And for every single one, we're gonna select 25. Kind of close, 25. I did it too fast. 25 and 25. So since we already got our dimensions, we are going to be able to complete our control volume. So now we're going to go from here to here. Once we see the little circle, that means that it's being aligned with the other line. So we click on that, we continue on that, boom. And we don't have to, we gotta do it, as straight as we can, but the program is gonna help us out aligning the lines. So now we're almost done with our geometry part, but now we gotta delete a couple lines here that we don't really need. Boom, 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 boom. So here we got line 9, select that, line 12. We're gonna select on that. We got 1, 2, 3, and 4, and our little circle. Now we are finished with the basic part, but we still need our surface. So we're gonna go back on our model. We select the sketch, and we're gonna have everything selected here. So now we're gonna go under concept, and we're gonna select surfaces from sketches. We're gonna click on that. We're gonna click on generate, and now we have our surface, and we are officially done with the geometry part of this assignment. Now we're gonna continue with the mesh part. Hey guys, so we have our little mesh here. So we're gonna have to go here, mesh, insert, and we're gonna select method. We're gonna select our entire control volume, and then we're gonna apply on that. We're gonna be using triangles, and we're just gonna generate that. And now it says that our mesh is done. Let's check on the statistics. That's a nice number. We're gonna change our element size to, let's say, 0.005. Boom. And we're gonna generate that. Let's just wait a couple seconds, and we're gonna be back once that's done. So I ended up changing our element size from 0.05 to 1 meter because I noticed that it was taking really long and my computer was running out of memory RAM. But now I see that everything's going down, so everything should be fine. Yeah, we reached all the way up to 30 something ish. So now that we have that, we are going to insert our sizing. We're gonna select that. We're gonna apply again, I guess. Element size. We should leave it like that, but we're gonna change that to 0.005, and we're gonna change that to hard, and that should be it, I think. Let's generate that again, and we're gonna be back once it's done. And now that we have that, we're going to have to insert our inflation. So our geometry is going to be the full body. It's going to be for this part, and the boundary. It's going to be that part, and we apply. For this part, we're going to have to select the first layer of thickness, and for this part we're going to go for let's see.
What I'm going to put here is, let me see what I did in my previous case. I put an inflation thickness of 0.02, for example, 0.02. Like here, I define 0.02, okay? And maximum layer, I put 100. I put 100 here.
Let's see, 0.02. And here we go 100, and here we go for 2.5. Now let's see. And now that we have everything selected, we just generate that. And so now it's meshing again, and he's at 5%. We're gonna be back once that's done. So since we got that, we're gonna define that as 0.15. So our mesh is gonna be finer, and we're gonna have better results. So we're gonna select that, and then now we're just gonna generate. And now we're just gonna continue once that's done. So now that it's done meshing, we're gonna have to define our boundary conditions. So we're gonna have to select here, we're gonna right click, and we're gonna create name selection. For this part, we're gonna be using it as our velocity inlet. For the other side, we're gonna be doing the same thing, but that's gonna be our velocity outlet. For our top and bottom, we can just name it as walls, but we're just gonna use symmetry since both are basically the same thing. And this part, we're gonna name it as our cylinder wall. And okay, so now we can see our different selections, and we are pretty much done here. Now we're gonna go back to our program or workbench, and we see that it's not checked yet, so we just right click it and update. Now we just give it a couple of seconds, and boom. So hey guys, so since we are basically done with the geometry part and the mesh part, we're gonna continue with the setup. The project is divided into 3 different cases, and the second case it has 3 parts. So for the first part, we're gonna start with the setup. Just give it a couple of seconds. In this case of precision, we're gonna use a couple of processors. Since we have the student version, it's not gonna let us go more than 4, so but that should be good enough. So we start, and we just give it a couple of seconds. We gave it a couple of seconds, and we just make sure that everything's running. So for the first case, we're gonna be using a biscuit fluid. So we go here, we change that, and we are given a 10 meters per second as a velocity. So we go under materials, fluid, air. The constant, we're gonna change that into 1 because it's gonna be easier just for us. And we are gonna go under, let's see, reference values. And here we're gonna have our velocity. We're gonna compute it from the velocity inlet, and so that's gonna be 10 meters per second. So the first part, it says that it requires to get the velocity and the pressure contours. So we're gonna have to go under initialization. We're gonna have to initialize. In this case, we use for the settings, we use just 35. And then after that, we're gonna run our number of iterations. We're gonna go and use 1000. And we're gonna calculate. Once it's done, we're gonna continue with this. Alright, so it's pretty much done now. And let's see. We got that as a result. And it says that we need the velocity and pressure contours. So we go here, on the graph, contours 1. Now use the pressure. We're gonna compute it and display it. Now we're gonna go for the velocity. Velocity magnet, compute, and display. Now it says that we have to do the plot for the pressure coefficient and velocity distribution. So we just go on their plots, x, y. And we're gonna save. So we have that as a recovery length. I'm going to put it to a file so we can use that with Excel, and that's gonna be, you know, a better graph. So we're gonna be doing the same thing for the pressure, using the pressure coefficient. We get the recovery length and the direction. Now for the drag and the lift, we go all the way down here on the reports where it says forces. For the drag, we're gonna be using X as 1, and for the lift, we're gonna be using Y as 1. So now we just print it, and that's gonna be our result. That's gonna be for the drag, and this is gonna be for the lift. Boom. And now we are gonna go for the streamline. In this case, we are going down here in the results. We double click on that and we just give it a couple seconds until it loads. Just give it a couple seconds. Now we get this as a result. This is gonna be our streamline. Okay. So now we are officially done with our first part. We're gonna continue with the second case now. So for the second case, we're gonna continue here. And it says that it's gonna be a viscous laminar. And we're gonna have to change our constant for the air. So if we look up the formula for Reynolds number, we're gonna see that it's the density, which is 1, then the flow speed, which is 10, times the dimension, which is 1. So now we just gotta find this, the viscosity. Since uh, since they gave us 150,000 as our Reynolds number, we're gonna substitute that here, and if we do just simple algebra, we're gonna get our constant as 6.67. So we change and create, and then we close that. So now let's see if we gotta change something else. Just verify that. Nope. We're gonna have to go on there. Let's just verify the reference values. As we can see, we have our velocity inlet, which is gonna be where our information is gonna be computed from. Here we got our viscosity, our velocity, which are right. So we just go under initialization, just like the last part. It's gonna be 35, and we're just gonna initialize. Boom. Now we're just gonna run our calculations, and same thing as last time, 1000, and calculate. Now we're gonna be right back once this is done. Okay, so our results are finally done. So it's asking us for the same thing as last time, to calculate the pressure and velocity contours. So we're gonna go back here, and same thing, we're gonna have to select everything here. It's gonna be for the velocity, compute, and save and display. So now we're gonna go and do the same thing for our pressure coefficient, compute, and display. Now we are done with the first part of the second case, but now actually we still have to plot the pressure coefficient and velocity distribution. So we'll go here where it says plot. We're gonna do our pressure, save and plot, boom. Now with the velocity magnitude, boom. As I see, I actually forgot to this information here on my file. So just going to do this. In my case, I use both. I use this data information from the ANSYS, and then now we're gonna show you guys how we do it using Excel as well. Velocity distribution. So we go here, it says write to file, right? And now it's telling us where to save it. Just so it's faster, we're just gonna make this as velocity case 2. Boom. And now we get back on our file location, which is velocity case 2. We right click it, open with Excel, just give it a couple seconds. We select our data. Now insert charts, and let's change that to velocity distribution. There. I mean, you guys can just right click it and do copy and paste, but I just like to use my my tool here. Let's go back here. Let's go back to the program. Now it's asking us to obtain the drag and lift coefficients for both. So we're going to do the same thing. We're going to go on the forces. In this case, we have already selected one for the y-axis, so that's going to give us our lift. This is going to be a result. If we do the opposite, 1, 0, print, that's going to be our drag. And now we're going to add the two velocities to the cylinder, which is going to be the other part. So we're going to go on there, recess, I think it was here, wall. We're going to use, it's asking us to do 20 and 40. We're going to apply that, close. And now let's just can use the energy equation for this part. It's still laminar. So laminar of air, tensor constant, blah blah blah. Now we go all the way there here where it says initialization. We're gonna initialize. Just it's gonna delete our current data, but we don't care about it anymore. And now we're gonna run our calculations and calculate. Now we're gonna be back once this is done. Alright, so our calculation is done. So now the same thing is gonna ask us to do the contours. So we're just gonna go all the way down here under results, graphics, contours 1. We're gonna select our velocity and then the velocity magnitude. We're gonna select all. We're gonna compute it and then we're gonna display it. It's gonna be our final result. Now we're gonna do the same thing for the pressure coefficient, compute, display. Boom. Now it says that we are required to do the same thing for the pressure coefficient and the velocity distribution for the plots. So we're gonna go here. We're going to cylinder wall, save and plot. We're gonna use curve length, same plot, boom. Velocity magnitude, just like the last time. It's gonna be a steady velocity, so we're not gonna see any changes here. So for the drag and lift, we're gonna go all the way down here, forces. This is gonna be for our drag, print. It's gonna be our result for the drag. On the lift, we are going for 0, and then 1. We're gonna print that, boom. Now it's asking us to do the streamline. So let's see. So many things open. We're gonna open here. Just give it a couple seconds. So once it's done, these are result. Let's move that. So now we are done with that part of our second case. Now we can just close it, and we're gonna go back here, and we just gotta change our velocity from -20 to -40. Apply and close. We verify that everything is right. go back here under initialization, initialize 35, and now we are going to run our calculation again, and we're gonna be back once that's done. Okay, so it's about to be done with this part. So our calculation is complete, and we are going back here. So we're doing the 40. It's asking us for the contours, so we're gonna go back here. We're gonna select that. We're gonna compute it. We're gonna display it. So that's gonna be for a pressure. We're gonna do the same thing for a velocity magnitude, compute and display. We're gonna get that. Now we're gonna have to plot our pressure coefficient and velocity distributions. We do the same thing. We're going to plot, and we're gonna that's weird. For some reason I have two plots there, but okay. We got our pressure, static pressure with the cylinder. Save and plot. Now we're going to continue with the graphs for the forces. We're going to print that, and we're going to get our values. That's going to be for our lift. This is going to be so for our lift, it's going to be for a lift, and this is going to be for a drag. I'm going to print that, and now for the last part, we're going to go and plot we're going to get a streamline. Just give it a couple of seconds until it's done loading. And that's gonna be our graph for this part. Now we are officially done with the second case. Let's go for the third case. So for the third case, it's gonna be a viscous turbulent flow. So we're going here, we're gonna change that here, since that's gonna be the easiest one to work with. Our constant is gonna change. Now our Reynolds number is gonna be 800,000. So let me just calculate that for 1 second. Let's go back. So let's see the formula, Reynolds formula. It's gonna be, so it's gonna be there. Let's use Notepad. It's gonna be 800 1 2 1 0. That. It's gonna be, our density is gonna be still the same thing, 1. It's gonna be 1 times the flow speed, that's 10, then diameter is 1, all over our viscosity, which is gonna be what we're gonna be looking for. It's gonna be 80 U equals to 10. So U equals to 10 over all that. We get the right number of zeros. We can just delete 1 0 there so we don't get confused. It's gonna be 1 over 80,000. 1 over 80. It's gonna be 125, which is gonna be this number. 1.25 e minus 5. It's gonna be our new constant for the viscosity. We're gonna close that. Let's see. Wall, cylinder in the wall. Oh, we're gonna change it to a stationary wall since we're gonna be not need that anymore. We're gonna apply and close. Now it's reference values. Everything seems no, that's not right. This is why we always gotta double check. There. Methods. Simple, presto, everything seems the same thing. Initialization, we're gonna initialize that 35, and now we're gonna run our calculation the same way as before, and we're gonna be back once that's done. Okay, so it's almost done and you just finish. So now the same thing again. It's gonna ask us to do the velocity and pressure contours. We go under contours and we're gonna display that. Oh, we're gonna compute it and display that. Boom. Now we're gonna do the same thing for the pressure. Pressure coefficient compute and display. Boom. Now it's asking us to plot the pressure and velocity distributions. We're gonna go under, where was that? XY. And that's gonna be for a velocity magnitude. It's gonna be, we're not gonna have anything there. And now for our pressure coefficient, save and plot, and that's what we got. Now it's asking us to do the drag and lift coefficients. So we are gonna go down here under forces. This is gonna be for drag, boom, and for the lift, 1's there and 0 here. We're gonna print that, boom, and now we just are missing the streamline. So once again, we get out of here. Just close. Yes, we're gonna do that. Just give it a couple seconds until it's done loading. Okay guys, so this is our final result. And alright. So that's gonna be everything for our project. Thank you so much. See you the next time.